Now we are going to study the effect of pressure on boiling point of water. What happens to boiling point of water when pressure increases? For this, consider a round bottom flask. Take a round bottom flask, then place it over a burner, then close it using a 2-holed cork, and through one hole a thermometer is placed and through the other an arrangement of steam outlet is placed. If it is placed over the burner and if you heat water, we can see as water gets heated in the flask, first you note that air which was dissolved in water will come out as small bubbles. When the water reaches 100 degrees Celsius, we can see that the bubble rise to the top and we can see the water begins to boil. As the temperature of the entire mass reaches 100 degrees Celsius, bubbles of the steam reach the surface and boiling is said to occur. The steam in the flask is not visible, but when it comes out of the steam outlet, we can see it as a foggy appearance. That shows that steam is coming out through the steam outlet. So 100 degrees Celsius water begins to boil. Now the steam outlet is closed using a small piece of cotton. Okay, by using cotton we can close this steam outlet. Now we can see that the boiling stops. So when the steam outlet is closed, we can say that the pressure inside the flask increases. Pressure increases and the boiling stops, means we have to apply more amount of heat to restart boiling. So this shows that as pressure increases, what happens to boiling point? Boiling point increases. Thus boiling point increases with increase in pressure. So in order to start boiling again, we have to give more amount of heat. Clear? Now remove the burner. Okay, remove the burner, allow water to cool to 80 degrees Celsius, some 80 degrees Celsius. Then remove the thermometer, remove the steam outlet and close the flask using a tight fitting cork and keep it upside down like this. Now pour ice cold water on the flask. Now the water vapor in the flask condenses, reducing the pressure on the water surface inside the flask. So now water begins to boil again, because here when you pour ice cold water, what happens to water vapor? Water vapor condense by thereby reducing the pressure. When pressure decreases, what happens to boiling point? Boiling point also decreases. Now we can see water begins to boil. Okay, bubbles are coming out and water begins to boil. So this shows that as pressure decreases, what happens to boiling point? Boiling point also decreases. So if you pour ice cold water, what happens? Water vapor condense, reduces the pressure. So what happens? The boiling begins to start again even at 80 degree or 75 degrees Celsius. So water can boil even at 75, 80 degrees Celsius if pressure is less. So as pressure decreases, what happens to boiling point? Boiling point also decreases. Thus we can say that the boiling point decreases with decrease in pressure. Hence we can say that as pressure increases, what happens to boiling point? Boiling point increases. As pressure decreases, boiling point decreases. And this explains why cooking is difficult on hills. Okay, in mountain areas or hilly region, cooking is very difficult. The reason is that high altitude atmospheric pressure is low. When pressure decreases, what happens to boiling point? Boiling point of water also decreases. So at hills and mountain region, water boils even at 80 degrees Celsius or 75 degrees Celsius. Water boils, but it is not enough for the food materials to get cooked. Okay, so that is the reason why at high altitudes cooking is somewhat difficult, but it is possible using a pressure cooker. Okay children.